Hi folks, my name is Robert Kothe. I'm here with a pretty exciting project, at least exciting for me. Let me give you a little background. For the last 5 years, my wife and I have been decorating our Christmas boat, or it's actually, we call it the Christmas boat, but we visit my in-laws in Florida, in Naples, every year for about 19-20 days or so. But that gives us enough time to kind of spread a little Christmas spirit and decorate the pontoon boat. Now, the pontoon boat is actually in a gated community, and it's inside a lake that requires electric motors only, no gas motors. So, you know, you're pretty much limited to electricity only. And while you're playing with electricity, you might as well just zazz it up a little bit and add some Christmas lights. So it started to snowball a little bit. The first year we put a bunch of lights on it, a generator went around, and people got excited when we drove past their houses. Because, let me explain, the lake, and I'll just put up a shot of the lake here, kind of meanders back and forth and back and forth. The lap is 3 miles long, and it takes a pontoon boat about a little bit more than an hour to go. So anyway, so for the past few years, we've always gone big with the decorating, and here's some past samples of the Christmas boat in the past. But this year was the first year that we put up the bimini, which is the sunshade, because we brought our dog down, a little Pomeranian. She's a sweetheart. There's a picture. She's gorgeous. And so we put up our sunshade, and of course, if you're going to put up the sunshade and leave it up, you might as well put Christmas lights on it. And something in my twisted brain said, the boat kind of looks like a train. All right, and that's the premise of this entire project. This bird's nest of garbage in front of me is the basis for my twisted brain going, the boat from the side kind of looks like a train. Now, we've always done Rudolph on the front and, you know, little Santa and blinking lights synchronized to music, but as soon as a train thing hit in my head, the investigation began. So let me go straight to the project. What we have here is this computer circuit board right here is called an Arduino. I have a second one right over here, okay? Now, what an Arduino is, I have a bigger version right up there. What an Arduino is actually a circuit board that can be programmed on a computer. The program can be transferred via a USB port into the Arduino, and then it executes the programming right off of the board. What's exciting about the Arduinos is essentially there's a whole entire vocabulary and entire library of programming already set up. So you can start with just simple instructions, and before you know it, you have it doing stuff. So it's a great way to learn electronics. It's a great way to learn Ohm's law, because they talk about resistance and all that good stuff. A little background about myself. Also a disclaimer. What we have here is some real high voltage wiring. Okay, this is 110 volts. It would hurt or kill you, all right? So unless you've had a background in electronics, I had 3 years in high school and 1 year in college, do not attempt this at home without supervision of somebody who knows what they're doing. Kids, do not try this, and if you do not blame me if you touch a hot wire. You're on your own. With that said, disclaimer aside, so that my brain basically said, okay, it looks like a train, but how do we get the wheels to turn? So the wheels in my brain started turning, and I did some small-scale tests. That for my business, I do website design, and we do flash animation, video production. So ultimately, I use the resources available to me, and if you see this animation behind me, I created a flash animation that essentially mocks up 3 channels, okay? So with this illustration, channel 1, channel 2, channel 3, slightly offset about 12 degrees, and then by the time it goes back to 1, it kind of looks like it's going to like 4, 5, 6 all the way around for a loop. So essentially having 2 crosses going 1, 2, 3, 1, 2, 3, 1, 2, 3, then the reality is 1 and 4 are the same, so it gives the illusion of spinning that way, or spinning a wheel, okay? And of course in reverse, if you do 1, 3, 2, 1, 3, 2, the wheel looks like it's spinning backwards, all right? So the magic of this whole entire project is this little device right here, okay? And we'll give you a close-up of it right there. This little device right here is called a relay. Now, the right relay can actually take a low voltage signal and then amplify it, or basically it throws a switch to allow a high voltage signal to run. All right, now when you see people with Christmas lights synchronized to music and every single note is programmed, more than likely either it's commercially bought or not, relay behind it. The computer would be fried if it actually pushed the kind of voltage behind here, okay? This is another Arduino, and after testing it on a temporary board, I soldered this down because part of the project, and you can see right here, this is going to be my dashboard for the controller. I've already pre-wired, hardwired. It's unplugged. So we're going to go high voltage now. So we're lit. Okay, this is hot. So no touching. So you can see right here, I've already hardwired a high voltage switch that's rated enough to do 120 volts, the right amperage. And this bulb, or equivalent, goes directly into a high voltage wiring. These are regular UL approved outlets, and you can see right here I have one outlet, and there's a close-up, one outlet that ultimately says switch. So I simply just wired a switch outside of the computer circuitry directly on the headlights of this, because when you're at nighttime going around, you don't always want to be blinding people looking at you, and you kind of know where you are, so you don't always need headlights on the train. But there's a switch on my dashboard. The rest inside this box is going to have this particular board that's going to be using the same Arduino as the side controller. And let me plug a battery in here and show you the whole premise behind the program. So it's already been programmed, the program's already been transferred. And here we go. All right. So what this is showing is I have a circuit board that has two sets of lights sequencing. So there's 6 bulbs. All right. And now this is called a potentiometer. Some people call them volume controls. A potentiometer is a way of regulating the voltage that goes to a circuit. I programmed it, and I'll get into the details of the programming in a little bit if people even care, so that in a boat, and here's an illustration, a boat throttle in the middle is neutral. When you push the throttle forward, you're going faster. The more forward you go, the faster it goes. Neutral is ultimately you're not moving, and when you pull it towards you, it goes in reverse. Well, just for fun, because it's programming, I programmed this volume control. Let me just place this down so that okay, so I'm in forward right now, and I'm in full speed forward. So we have 2 sets of lights here, and one set of lights is actually signifying, I'll put it in neutral to figure out which set is what. Okay, let's go to neutral. There we go, we're in neutral. Okay, so this blue set of lights is actually signifying the gear that the boat is in. So I'm in neutral right now, and so therefore I've also programmed the relays so that channel 1 is on, so the wheel is not turning of the train. So, but as you'll see in this illustration that I have of the train itself, I also have a fake smokestack on there, and that's going puff, 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 puff. Now, if I use the same channel in neutral, it would stop puffing, and in reverse, it would look like the smoke is going into the train, which is silly. So I programmed a secondary channel that always goes puff, 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 1, 2, 3. So this is first, second, third, and that's the red channel right here. And that's going to synchronize to a second set of outlets, and I have high voltage for all outlets within that. So let me demonstrate on small scale, and this is also the circuitry that can be used for my dashboard, which is why I made it permanent. So I'm going to go forward just slightly slowly, and now it's moving slowly. And I'll explain the logic behind the programming in a little bit. So 1, 2, 3, they're both going 1, 2, 3, 1, 2, 3, 1, 2, 3. As I turn the knob a little faster, it's going faster. The smoke's going faster, the gear's going faster. Okay? And finally, if I go really fast, it's going really fast. I'm going to start backing off the knob, and we're now heading towards neutral. I'm in neutral. Okay, so I'm in neutral because only channel 1 is on and the smoke is still going. And that's another reason for the dashboard is I don't want to keep sticking my head over the side of the boat to see what gear the boat is in if I only had a wheel. So this case with this circuit board inside is going to give me feedback as to how fast it looks like it's going. Now I'm going to turn it into reverse, And what you're going to notice as soon as it kicks into reverse, of course, it starts slow in reverse. Now this board is going upward and this board's going downward, so up and down. So ultimately, it's going to go channel 132, 132, 132, 132. All right? And the more I turned it into reverse, the faster the smoke goes and the faster the wheel goes. So the smoke's still going forward, and the wheels, I'm going to slow it down a little so you can see on the computer how it's working. Okay? And that's the logic behind the train. Now, to get into the details on full scale, I have a second Arduino. I'm going to unplug this battery. I'm going to plug this battery. I've already got the high voltage on. So I'm going to plug 3 sets of Christmas lights into our high voltage system. Alrighty. Still high voltage on there. As far as the headlight, I'm going to move this closer this way, move that there. Okay, so I'm going to plug in. The electricity is already lit. So what's going to happen here? Oh, and let me explain. So what happens with the Arduino, usually just for fun projects, you light up little LEDs, as we have right here on this project board and the permanent project board that I made over here. But by putting it on a relay, the relay then throws a switch for high voltage circuit. So I'm plugging in the Arduino now. Boom. Okay. 1, 2, 3, 1, 2, 3. Or it's sequencing now. So what's happening here? Let me explain the programming behind the Arduino. So I'm in forward, and I don't have the smokestack channel wired on with the extra lights, but they're always going to go 1, 2, 3 with the sequencing. So the programming goes like this. And by the way, this is as exciting as it goes, so you might as well turn off the tape right here as far as the project is. But if somebody wanted to replicate it or understand the programming behind it, then continue to watch. But no one's going to be insulted if you turn it off at this stage, because I'm just going to get into gobbledygook computerized details. Okay? So the programming is as such. I'm going to slow it down now. There we go. Okay, wait, faster. Okay. So we programmed it as such. What it does is the Arduino reads the number coming off of this potentiometer. It gives a value from either 0 to 960. It just turns out that's the value that it gives upon closer examination. And it takes that value, and what I found is that if it takes that value and I put in like a millisecond pauses based on that value. So a 0 pause, or sorry, a speed of 40, for example, would only give a 40 millisecond pause between being on, waiting 40 milliseconds, on, next one, wait 40 milliseconds, and up. As you slow down the volume knob, the number gets higher. Well, actually, I'm going the wrong direction. But the number gets higher, and the system gets faster. Okay? So as the system gets faster, it means that the pause has been decreased. Okay? So what I did is I read the potentiometer. I then added 40 automatically because I wanted a minimum speed of the 40 fastness. And then I took the value and in forward allowed it to use that value for the pause. So again, the smaller the value, the higher the value, the slower the thing goes. And then as we speed it up, it's just a slower pause. There we go. And this is the full scale path. Now neutral, what I did is I took the spectrum, and as you can see on this illustration, anything between from 1,000 now, because I added 40, 1,000 down to about 570 is going to be reverse. In the middle is neutral, that little sliver right there. If it's within that sliver of the volume control, I basically just said turn channel 1 on, and that was neutral. And of course, 1, 2, 3, it still weighted the 1, 2, 3, 1, 2, 3. So left 1 on, and then the other channel just kept counting for the smokestack. And then finally, for forward, once you cleared the neutral zone, it progressively got more and more based on the value that came off of the potentiometer, and it would then increase the speed in forward. So how did I handle reverse? Because the problem is that reverse would have been ultra slow because it's the high number of the spectrum, and it would be an opposite. To the middle will just, so what I did is I took the value and I put an if-then statement inside there, ultimately saying and here's the breakdown of it. If it's between here and here, go really fast because that's the highest spectrum. If it's between there and there, go a little slower. Between here and here, go a little slower. Here and here, slower, slower, slower. And then finally the slowest you can possibly go before you hit neutral. Okay. If anyone asks, I can always share the programming with you if anyone wanted to replicate my results with their Arduino. The magic of these Arduino boards is they're only about $20 a piece. And again, with a starter kit of about $50, LEDs and boards and things like that, you can actually having LEDs blinking in no time. Once again, add in the relay and you got magic. Okay, so that's it for now. And the next time I record, I'm going to imitate Matt Johnson. Matt Johnson is one of the people who's on television for over-the-top Christmas display using nothing but pixels, which are red, green, and blue. Every single pixel is programmable. But he has wreaths that he makes that he hangs from his trees, and I'm going to follow his program on how to route out grooves and put metal in it and weld the metal to make circles. And then his cross beams are just to keep his wreaths from collapsing. My cross beams are going to be the spokes of the wheel. So we're going to get into that in my next video, but in the meantime, electronically, we're good to go. If you're still here and if you're still paying attention, how did I program this? Well, again, they have sample programming. And the sample program is the fact that starting with just blink, you can see the syntax using the Arduino that simply just makes it blink. I'm going to unplug this channel. Okay, we're going to go back to the little guy. And so with the Arduino, you kind of start small scale, knowing full well that the relay is going to work. So knowing that the relay is going to do its job and transfer it to the Christmas lights. So what happens is that once you have your Arduino board getting a bulb to blink, there was another sample project that sequence blinked it. Blink, 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 blink. And it actually did it with 4 bulbs. I'm thinking, okay, find the 4th bulb, remove all the lines of program for it, just comment them out, and boom, now you've got 3 channels blinking. So, and then I found another program that took the value of a potentiometer and made something blink faster or slower. And I'm thinking, this is fantastic if I can just weave them in together with the now 3 blink and declare a variable and take that variable and weave it in. Now I could add it into here. So the point is that between the syntax available on the sample, when you get error codes on your Arduino, I Googled the error codes and figured out where I lost a semicolon or not. And then finally, you know, when I was all ready to go, we just, you know, just piece by piece by piece started programming it until it worked perfectly. In my defense, I actually have a background in computer science. My degree is in business with a minor in computer science. I do not know C++ programming, but I know algorithms and programs well enough to have made this work. So it may not be a starter project for your average person, but again, upon request, I can always email you the coding, plug it into your Arduino, and then just follow which channel plugs into where. So thanks for listening to my rants. I can't wait to see this on the boat. I can't wait to show you some full-scale samples of the wheel turning, as simulated here on my flash mock-up of the wheel actually turning and the smokestack turning, as I did in my mock-up. But in the meantime, I'm really excited to know that the actual programming is done, the hardware is almost done, and everything is where it needs to be. So I'm Robert Kothe, and thanks for watching.